This is HIV Antiviral Resistance Evolution in plain English. First, let's do a quick overview of HIV. At the end of 2008, approximately 34 million people were infected with HIV. Currently, there are 42 million people carrying this disease. That's an 8 million case increase in 2 years. As there is no cure or treatment for HIV, the lifespan of infected individuals is drastically reduced. HIV evolved from a pool of SIV, or simian immunodeficiency virus, which is also known as the African green monkey virus. It is believed that the first case of HIV originated in Africa when SIV was transferred to humans as a result of SIV monkeys being killed and eaten, or their blood getting into cuts or wounds on the hunter. Normally, the human would be able to fight off the SIV virus, but at some point, human hosts selected for SIV variants capable of replicating in humans, thus creating HIV-1. It is thought that there are many slightly different genetic strains of HIV because each time the virus was passed from monkey to human, it changed in a slightly different manner, thus producing a different strain. HIV has a sloppy replicase, which is a bad thing in HIV replication because lots of defective virions are produced. However, this helps HIV survive triple cocktail therapy by generating resistant replicase genes. Genetic differences in the HIV strains cause conformational changes in the enzyme produced that prevent binding of the antiviral drug. This is similar to changing the shape of a jigsaw piece so that it no longer fits together with the next piece. In order to control the replication of HIV, a drug cocktail therapy is prescribed. Person 1 has not been taking drug A. When he is given drug A, only the resistant strains survive. Person 2 has been taking drug A for some time, but when he stops taking the drug, the non-resistant strain becomes more prevalent. He then takes a strong dose of drug A, which reduces the total viral load. Person 3 has been taking drug A and has a resistant viral load. Cocktail therapy can be administered by giving drugs B, C, and D, and few forms survive. Triple cocktail medications contain 2 nucleoside analog drugs and a protease inhibitor. The combination of drugs helps to reduce the concentration of virions in the bloodstream by affecting the enzymes in the virus. After several rounds of triple cocktail therapy, 1 or 2 resistant HIV strains will arise. These strains give rise to an increasing population of viruses, which requires a treatment change. This graph shows that once a type of therapy becomes insignificant in treating HIV, HIV RNA copies approach higher levels. At this point, a new therapy is administered, causing the HIV virion levels to drop, sometimes below the level of detection. This trend continues as each new drug selects for HIV resistance. For this patient, 3 treatments were required over a 100-week period. This indicates that the HIV virus is continuously changing and new strains are being selected for that are resistant to the current drug therapy. Because of this, drug therapies will have to evolve over the life of the HIV virus to account for the newly resistant HIV strains. This was HIV Antiviral Resistance Evolution in plain English.